The previous video showed a statistical reason of what happens to your hypothesis tests when you increase your sample size. Larger samples have higher power, and what that means is you're more likely to detect a difference in your sample versus what the null hypothesis says than if you had a smaller sample. What I often like to do is, when we're talking about new ideas and concepts, is to try to use a metaphor outside of statistics to help explain it. So let's say I have a picture on a file, but I don't know what it's a picture of. And let's say that I believe that it's cake because I like cake. So without any other evidence, I'll believe it's a picture of cake. And I'm going to keep believing that this picture is cake unless someone gives me evidence to the contrary. Someone has pretty compelling evidence that this picture isn't cake. My null hypothesis, my default belief is that the picture that I don't know about is of a cake, and my alternative hypothesis, what I need evidence for, is that the picture is not of a cake. Well, what can we do? So we have this unknown population. I don't know what the picture is of. I have my belief about it, and I have an alternative explanation that I need evidence for. And the idea of how it works in statistics is we'll take a sample from the population. So instead of taking samples of peoples or trees, let's say we'll just take a sample of pixels. And we'll start off by taking a tiny sample of pixels. And if we only take a small sample, this is what the picture looks like. And just based off of this sample of pixels from the actual population itself, doesn't look like anything. So could still be cake. This isn't evidence that this picture underneath this black box isn't cake, because the sample is real small. What we can do then is, let's say I took, instead of a tiny sample, a smaller sample of pixels from the actual picture itself. Still can't really rule it out. The picture could be anything, including cake. No evidence to the contrary yet. Now if we go out and we take a medium sample of pixels, as the number of pixels in our sample grows, the picture becomes clearer, and the easier it is to tell what the picture that represents our population is. It's pretty clear from this picture that it's not a picture of a cake, because it looks like two cats, or at least two animals hanging out in a window. Don't know that's what it is for certain, but just based off this medium sample of pixels from the population, I can probably rule out it's a picture of a cake. May not know what it is exactly, but pretty confident it's not cake. And then if we take a really large sample, we'll get a really clear picture of the population. And from this large sample, really compelling evidence that the picture isn't of cake. And this is kind of where the errors that we can make are a possibility. Here, this population clearly isn't of a cake, and if I just took a tiny sample, high chance of committing a type 2 error. I wouldn't reject my null hypothesis from this picture. The picture isn't of cake, but I'm not getting rid of it, so I'll still believe this picture is of a cake, even though it's not. Small sample, still high chance of a type 2 error. Medium sample, that chance went down, pretty compelling evidence that it's not cake. And then the large sample had a really strong chance of rejecting my null hypothesis. Now this is still a sample, it's not proof that this picture isn't of a cake. There's a chance that we happen to get just a random sample that looks different than the population itself. Or if you kind of think of in our metaphor here, maybe these are cake cats, that someone who's really good at decorating made cakes that look like cats. So it could still be a picture of a cake. And that's kind of what the significance level does. It determines which stage of these pictures is strong enough evidence for me to reject my null hypothesis. If I have a high significance level, then maybe the tiny sample would reject it. If I have a very, very small significance level, that means I require a lot of evidence to change my mind, which means that maybe even this large sample wouldn't do it. So your sample size determines what the picture looks like, and your significance level determines how clear the picture needs to be before you say that you don't think your null hypothesis is true. And in this case, it didn't take that large of a sample. Our medium sample worked because the population is very different from what the null hypothesis says we should expect, meaning our null hypothesis is very wrong. And those are the three things that impact our chance of rejecting. Our sample size, the larger the sample, the clearer the picture. Your significance level, at what stage of these pictures would we reject our null hypothesis? The smaller the significance level, the farther along we would need to reject our null hypothesis, because the more convincing evidence I would need, and then how wrong the null hypothesis is. Since this is a picture of cats and not cake, you don't need that large of a sample before you can figure out that it's at least not a cake. Maybe not know what this is exactly, but it's not cake. Whereas, let's say we had a different picture. So I still believe this is cake. I have a second unknown picture, but I'm not going to change my mind. I'm still going to believe that it's cake for this unknown one as well. So we'll do the same thing. Go out, take a tiny sample. Can't really tell anything about what the actual picture is from such a small sample. There's this brownish blackish object here in this white area, so maybe this is a plate and this is a cake, but can't determine that from the picture. If we take a small sample, it looks like something maybe on a plate, some brown object, which could be cake, could be something else, could be a pie, or it could be bread, or it could be a steak, who knows, but it looks like some sort of food item on a plate maybe. So we take a larger sample, and that kind of looks like a cake, right? We have this object that it's laying on, like a plate or a cutting board, and this brown object with white frosting on it, maybe. So this medium sample doesn't contradict it either. It's not compelling evidence that this population isn't a picture of a cake. Compared to the previous one, where our medium sample, since the null hypothesis was wrong by a lot, it was pretty easy to reject it. This time, the medium sample didn't do that quite a good of a job of convincing me that this isn't cake. We take a large sample, and now it's pretty compelling that this population probably isn't a picture of a cake. It looks more like a loaf of bread. Could be a cake. Can't necessarily rule it out completely, and again, that'll play the role of the significance level if we reject from the medium sample picture or the large sample picture. But if I want crystal clear evidence that this is a picture of something other than a cake, I can take a very, very large sample, take a lot of pixels from the population. That should paint a really clear picture. So if we take a huge sample, I think there are about 400,000 pixels in the original image. I took a sample of 100,000 pixels, and this is what we get. And it pretty clearly indicates that picture behind here isn't cake, but a loaf of bread that my girlfriend made. And if we look at our population, it matches it really, really closely because we took such a huge sample. The larger a sample you have, essentially the more pixels you're pulling from the picture, the more you know about your population, the better of an idea of what the population looks like. The better idea you have of what the population looks like, the easier it is to contradict the null hypothesis when it's wrong. Another metaphor I like to use when we're talking about sample sizes and hypothesis tests is it's acting as our zoom of our microscope. The larger sample size we have, the closer we can zoom in to what we're looking at, and the easier it is to tell if the null hypothesis is wrong. We have two different letters here. And I'm going to believe that since I can't really see them, since we're zoomed so far out, that both of these are the letter A, and my alternative hypothesis is just going to say that they're not the letter A. And because we're so far out, I can't quite tell what these letters are, but what I can do is I can use the zoom function down here to magnify what the data is trying to tell me. So if we click zoom in, it still can't quite tell what it is because we didn't zoom in that much. But if we take a larger sample, we're magnifying our results more and more and more. So the larger a sample we take, the higher this magnification is becoming, the more we're zooming in. And the more we're zoomed in, the easier it is to tell if this letter is A or not A. And can't quite tell what the letter is right now, but it definitely doesn't look like the letter A. So maybe at a zoom of 270%, I don't believe it's the letter A. Don't know what it is, just that it's pretty compelling to me that it's not A. We keep zooming in though, more and more, it gets a better and better picture of what we're actually looking at. And now it pretty clearly looks to me like the letter J, not the letter A. There appears to be a pretty clear difference, and that because we zoomed in so far at 360% magnification, if we had a really large sample size, then we can tell that our sample data is different than what our null hypothesis says. J is clearly different than A. And we could tell that without having to zoom in too close. Well, there's another letter down here, and this one's going to look a little more like the letter A than J does. meaning that it's going to take a larger sample to determine that null hypothesis is wrong and the letter is not A. So we'll zoom in. Every time we click our zoom in, it's like we're taking a larger sample. It magnifies the difference between our null hypothesis and the alternative hypothesis more and more and more. And that kind of looks like an A from where we are, even at a zoom of 250%. And it still looks like an A to me. Still no compelling evidence that the null hypothesis is wrong. We zoom in more and more. It's kind of maybe not an A. There doesn't appear to be a leg on it at 370%. Still kind of hard to tell that the null hypothesis is wrong. But if we zoom in as far as we can go, it maybe not completely strong evidence, but it's pretty compelling. That's not the letter A, probably the letter O instead. And the reason we had to zoom in so much closer is because the letter O and the letter A look very similar. If your null hypothesis isn't that wrong, it's going to take a larger sample to indicate that it's wrong. Fair coins aren't actually fair. If you flip a coin, it comes up on heads about 51% of the time. 51% is the actual population proportion. Usually we treat the coins as fair with a population proportion of 50%. The null hypothesis is wrong. The coin's not really fair, but it's not that wrong. 50% and 51% are pretty close. If you wanted to show that the coin wasn't fair, you'd have to flip a lot of coins. So that way a 1% difference shows up as significant.